So, today we will demonstrate the measurement of thermal expansion coefficient of a metal rod. So, this is the experimental setup for measuring the thermal expansion of a metal rod. Okay. So, now you see here this one setup where this one is called micrometer, and this rod, when rod will be expanded. So, this arrangement is done in such a way that how much it is expanded. So, this from this reading we can tell there is the expansion of the rod, and now why rod will expand. So, if we increase the temperature of the rod, then it will expand. How much it is expanded, so that reading we have to take, that will be taken using this micrometer, and with temperature that expansion will increase or decrease depending on whether temperature is increasing or decreasing. So, that reading, so this reading of the temperature also we have to take. So, this here we will get basically the this reading of the temperature. So, now let us see where is the sample then. This will measure the expansion coefficient of a rod. Where is the rod? Rod is basically, I have to just, I can open it, just I can open it, okay. Then actually here this thermal insulator, asbestos, as is called, I think yeah, ceramic kind of things is used. So, this rod is basically inside of this ceramic cylinder. So, now surrounding the rod there is a coil, or there is a coil, heating coil basically. So, this current here you can see from here it is written oven, here is written oven. Okay. So, this, that means from here basically we are passing current through passing current to the coil surrounded this rod, metal rod. So, that metal rod we cannot see, as I told you. So, but this current is given to the rod, not rod, to the coil. So, that is basically oven. Now, this power, if power is higher, then this temperature of the oven will be higher. So, this temperature of the rod will be higher, right. So, now I have to measure the temperature also. So, there is a temperature sensor. Actually, here you can see that it is written temperature sensor. This is basically a thermocouple. Here this is the temperature sensor, this is a thermocouple. So, this one end of the thermocouple is basically near the rod, okay, where the temperature of the rod can be measured, okay, can be detected. So, temperature sensor will tell this meter this what is the temperature at the sample point. So, that will be displayed here. So, that is the this temperature measurement is based on the thermocouple principle. Okay. So, this is one part. Second part is just we are this control of the power, this oven power. Okay. This basically current in the coil, we can control the current in the coil, so that we can control the temperature of the sample. So, here you can see set and measure, here wait and run, okay. wait and run. So, temperature control, basically this is a temperature controller, and it is called PID controlled oven. Okay, PID controlled oven. What is PID? PID, this full name is proportional integration, integral and differential. Proportional, integral and differential controlled oven. Okay. So, I think I will describe what is the how it works. So, here you can see this wait and run and the set and measure. So, now rod is in a oven, power is given from here to the oven, and what is the temperature of that rod, that will be noted down, that sensor thermocouple will tell to this meter. Okay. So, here there is a scope to set the temperature. Say I want temperature say 150 degrees centigrade. Okay. So, then I have to put knob here, then I can switch on this where it is, I think is back side switch or front side switch, turn left, this one, oh this one, on and off. Okay. So, it is on and off here. Okay. So, it is on. So, whatever here you are seeing this, it is basically it is showing temperature. So, already oh, this is set temperature. Here you see this knob is at set, means I have put this temperature set. I think here I can rotate to change the set temperature. Say I will set at 150 degrees, 150 degree. Okay. So, this set. Now, if I put here measure, so what is the actual temperature now of this rod, of this oven place? So, that is the actual temperature. Okay. So, 19.3, that is the temperature at right now. Now, wait means here I am telling this instrument that you do not send power to the coil oven. Okay, wait. Now, if I at this condition, so rod place their temperature is this. Okay. So, I have to note down this temperature, and at this temperature what is the what is the reading of this, that I have to note down. So, here this micrometer, so here you can see this is written 1 micrometer. So, this list count of this micrometer is basically 1 micrometer. Okay. So, here initially I have to note it down the reading of this micrometer, it is 0, it is 0. So, at 19.4 or 3 degrees centigrade, the micrometer reading is this. So, this I can take the original length of the length of the rod, okay, at this temperature. Now, I will increase temperature, and then rod will expand at different temperature, and that how much it is expanded. So, that we will get from this reading. So, here I have set at 150 degree. Then now, if I just put at run, so this temperature will increase. Here you can see this temperature reading will change. So, it is better. So, if you want this faster change of the temperature, so we should set at that set temperature at higher value. Anyway, so this temperature is changing. 19.7 now, 19.8 now. Okay. So, this reading is coming from the temperature sensor, and I have set at 150 degree centigrade. That means, this change of temperature will continue as long as this it reach to the 150 degree centigrade. So, this PID control means it will automatically it will set at 150 degree, but you know this, to change the for changing the temperature, this system is getting there is a feedback loop, you know. It's just every time it is what is the set temperature and what is the present temperature. Okay. So, it is taking this temperature difference. If temperature difference is higher, so it is giving power to the coil proportionally. The temperature difference is higher, set temperature and present temperature. So, this power, so power is given to the oven, that is proportional. Okay. And then it is when it will go to close to the 150 degree, but it cannot just suddenly, it cannot just go to 150 and stop. So, what it will do, it will go beyond 150, say 155, then it will say no, this temperature is higher now. So, it will come. So, then here basically integration and proportional. So, because slight change here, this it is not this high gap. Now, from 150 that change is within plus minus 5 degree. Okay. So, then it is basically do the integration, this feedback, its power is given through the integration circuit, and then if it is very close to the that 150 plus minus 1. Okay. So, then it is basically you know the slope, differential slope. Slope basically at a particular point. So, that is the slope at a particular point. Okay. So, it is the slope is nothing but differential. Okay. So, there is a differential circuit also. So, when it is very close to 150, okay, plus minus 1 degree. So, there it use this differential circuit for applying current to the power to the oven. Okay. So, this is the method this power supply, this controller is used. So, that is why it is called the PID controller. Okay. So, now you see this temperature increasing. Okay. Initially our is a 19.3, what was the reading? Now you see reading is change. What is the reading you can find out. So, at 30 I will note down this one is I can see 1 to 3.5 or 3, 4. It is between 3 and 4. So, I will note down that reading. So, at every 10 degree, so initial say it was 19.3 around 20. So, then I took reading at 30, then I will take reading at 40, or you can take reading at each 5 degree change of the temperature. Okay. So, I am noting down the temperature. Okay. Initially 19.3, then this reading was micrometer reading was 0. Okay. Now, 30 degree micrometer reading is 3 or 3.5, one can write approximately micrometer. Okay. Just you can guess between these two division, two lines. So, it was around in middle. So, at 35 you want to take reading. So, you see now it is 14. Now, I can see it is 14. Okay. So, at 35 it is 14, 30. So, exactly you have to take. So, you have to be ready for taking reading. Okay. So, then 40, 50. So, up to maximum I think we will go, because this meter works up to 200 degree centigrade. Okay. So, its limit is 200 degree centigrade. So, I think we will take them reading up to 150 degree centigrade each. So, I will get, if 10 degree difference if I take reading, I will get 15 sets of reading. And now, that working formula is very, very simple. You know, working formula is very, very simple, right. So, this you know this linear expansion expression L equal to L0 1 plus alpha t plus beta t square plus gamma t cube etc. So, generally beta and so all are thermal expansion coefficient, this is the first order, this second order, third order. So, this beta first, second order, third order, this coefficient are very small compared to this first one. So, that is why generally we keep up to this first order. Okay. So, at temperature T, so I will not tell temperature, actually temperature difference, what about original temperature? It was 20 degree in our case. So, at 30 degrees, so this T is basically T minus T0. Okay. So, it is a 10, so it is a delta T basically. Okay. So, this L means length of the rod which was L0. So, that is now L. So, L equal to L0 1 plus alpha t. Now, alpha equal to L minus L0 by L0 t. So, this is basically this t as I told delta t and this delta L. Okay. So, one can write del L by del t 1 by L0. So, here we are getting basically this due to the temperature difference from the original one, of course, L0 corresponding to the temperature T0. Okay. So, this for temperature difference from the original, what are the increment of the length that we are noting down. Okay. Now, if you plot, so you have data for temperature as well as for this expansion delta T and delta L. Okay. So, you can plot a graph, you have 15 sets of data. So, basically you will get a more or less linear curve. Initially it is a linear, then because of this other parameters, it is higher temperature, it will curve. Okay. It will curve, right. So, here actually our measurement L0 is given. In our case it is I think 55 centimeter. In our case this metal rod is a 5 centimeter. Okay. And now del L by del T we will find out from the graph, and then easily you will find out this alpha. So, I think I will. So, now you see the 55 it is increasing, and every time you have to note down. So, experiment is very simple here. Here actually this is a thermocouple is used for measuring the temperature, and also this thermocouple is helping for feedback for this PID controller, because set temperature and that actual temperature, depending on the difference between these two, as I told, this proportional integration and differential, that circuits are there, which one will be in which circuit will give power to the oven. So, that will be decided by this controller. Okay. So, and here you see this micrometer, it has, if you just push it, then it rotates. So, these are scaled. So, how much push? So, depending on this rotation will be there. So, that is the basically micrometer. So, this rod, it is here metal rod, and then on top of it this some glass rod is there, and just this some Teflon kind of things here, just it should be to make it just plain surface. Okay. On glass you cannot put this one, it may break. So, this just Teflon cap we have used. Okay. And on top of it this micrometer, this yeah, what I should tell, this the pointer is there, this pointer is connected with this what I think this push rod at the bottom. So, if it is push, how much it is push? So, that is the reading is given accordingly. So, why it is pushed? Because of expansion of the rod. So, that is why the expansion of the rod is directly related with this reading, and temperature from thermocouple we are getting from here. So, temperature versus this expansion, that data only we have to take, and as I told, from plotting graph you can find out del L by del T, and you will get this linear expansion coefficient. So, I think in next class I will discuss about the data analysis and error calculation. So, I will stop here. Thank you.